In this module, we shall cover cryptography, a concept indispensable in the current information security scenario. With data compromises and security breaches on the rise, the amount of loss of information is indeed something to ponder upon. It is important to understand the role of cryptography in such situations and applying protection measures based on it so that proper security systems are put in place to mitigate such losses. Just like many other technical topics, cryptography has its own lingo. What is shown here are just few terms that we are going to encounter while learning this concept. The first is plain text. It is basically the message in its natural format readable by an attacker. Ciphertext. It is defined as the original message altered to be unreadable by anyone except the intended recipients. Key. Now this is a sequence that controls the operation and behavior of the cryptographic algorithm. It is more often than not a string of characters with a mix of alphabets, numerals, and special characters. Key space. As the name suggests, it is the total number of possible values of keys in a cryptographic algorithm. Initialization vector. It is a collection of random values used with ciphers to ensure no patterns are created during encryption. Cryptosystem. To encapsulate all of these terms into a single system, the term cryptosystem has been coined. It is a combination of algorithm, key, and key management functions used to perform cryptographic operations. So why is it necessary for us to care about cryptography when it comes to information security? Well, here's what it can do for us. When it comes to resources, confidentiality means that only authorized entities are allowed to view corresponding resources. This service ensures the message was not altered by unauthorized individuals, thus validating the identity of the user, hence the integrity. Authenticity. As the name suggests, it validates the source of a message to ensure the sender is properly identified. Non-repudiation. It establishes sender's identity so that the entity cannot deny having sent the message. Access control. Access to an object requires access to the associated crypto keys in many systems, for example login. This service ensures that such access schemes are properly constructed and employed. Understanding the functions of each of these crypto system services goes a long way towards understanding the nuances of the protection schemes of a security system. Well, we just went through the services offered by cryptography. Now dealing with some of the issues that may arise in establishing a cryptography system becomes important as these issues could undermine the cornerstone of such systems. Some of these issues are confidentiality. This means that only the sender and the intended receiver should understand the message content with the underlying process as A. Sender encrypts message and B. Receiver decrypts message. Second point, the endpoint authentication. This implies that the sender and receiver want to confirm each other's identity, a very important issue dealing with cryptography. The third is message integrity. The issue takes into consideration that the sender and receiver want to ensure that the message is not altered, either in transit or afterwards, without any kind of a detection. Moving on to a more illustrative example, or in fact, a funnier looking one. The figure on the screen says it all. Here, we have two people, lovers in fact, called Alice and Bob, who want to communicate securely, and Trudy, who looks like the devil incarnate, wants to intercept their communication and see for herself what is being talked about. The data is being sent through secure channels with proper endpoint authentication. What makes this communication secure is that the plain text is being converted into ciphertext before being transmitted on the network. So Trudy is intercepting the ciphertext, which is impossible for her to decrypt unless she knows the corresponding decryption key, thus making the message transmission secure. If M is the plain text message, then the message is encrypted with Alice encryption key KA, and at the other end it is decrypted with Bob's decryption key KB, by which the plain text is recovered. Now this process may not be this simple in practice, but this is the gist. and with various other security parameters, it makes a good crypto system. Now we shall see the types of cryptography systems based on the type of input mechanism of the message or input data. The major types are stream-based ciphers and block ciphers. Stream ciphers take the data input in the form of a stream and mix the key stream in the plain text to produce relevant ciphertext. Block ciphers, on the other hand, accept data input in the form of blocks instead of data streams. Stream ciphers are fast and easy to implement in hardware and thus are good for real-time services. Block ciphers are stronger but slower and often implemented in software. Now just a brief introduction to the different types of encryption systems. The encryption systems majorly used in today's crypto systems comprise of substitution ciphers, transposition ciphers, monoalphabetic ciphers, polyalphabetic ciphers, modular mathematics, and one-time pads. These types basically describe the patterns of changing the plain text to ciphertext from a substitution cipher using letter replacement to transposition ciphers, which include word jumbles while rearranging or reordering letters within the message, or monoalphabetic or polyalphabetic ciphers where single or group of letters are substituted for plain text to ciphertext. Also mentioned here are one-time pads, which are randomly generated keys used to ensure a high degree of entropy in the encryption system. Now we shall discuss some very basic methods used in cryptography. Cryptographic algorithms generally fall into one of the two categories or are a combination of both. The types of methods used in cryptography are symmetric, asymmetric, and hybrid techniques. The overview of such methods is fairly simple, with symmetric cryptography being the use of same key for encryption as well as decryption. The major issue that arises here is the safe distribution of the key to the communicating entities. In asymmetric cryptography, a key pair is used for encryption and decryption. The catch here is that the keys are mathematically related, and the most common example is public key encryption schemes where the key pair contains a public and a private key. The public key is used for encryption while the private key is used for decryption. For hybrid approach, it combines strength of both methods, utilizing asymmetric approach for symmetric key distribution, the key being named as a session key, and the data encryption implemented in symmetric mode. Now, while symmetric encryption is fast, it offers only confidentiality and needs a secure channel for key distribution. Asymmetric cryptography is relatively slower and complex and provides authentication and non-repudiation. Moving on, we shall now see the concept of digital signatures. As the name suggests, it is a cryptographic technique offering services akin to that of handwritten signatures. It is ideally supposed to be verifiable and non-forgeable. The goal is similar to that of a MAC, that is message authentication code, except that it uses public key cryptography. The diagram here illustrates the concept of how a digital signature works. For the message M shown here, Bob encrypts the message with his own private key, which is known as the process of signing. This signing is necessary to provide non-repudiation service to the message or data. Another illustration of the said process is when the digital signature is in the form of an encrypted message digest. In this diagram, Bob first creates a hash of the message and then de-encrypts it with his private key to create the digital signature. For verification of the signature, Alice creates a separate hash of the same message and on the other hand decrypts the message digest using Bob's public key. It then compares both the values. If they turn out to be equal, it means that the signature is valid and verified. The process states that the verification process is done by applying the public key of the owner, and in the previous example, Alice verifies that only Bob signed the message M. For proving the same, she can take the message M and signature KBM to court and prove that Bob was the one who signed the message or data. Listed here are some common symmetric algorithms such as DES, 3DES, AES, IDEA, Blowfish, and the like. DES or Data Encryption Standard has a 64-bit key that is effectively 56 bits in strength. Common DES modes include electronic codebook, cipher blockchaining, which is most commonly used for general purpose encryption. Cipher feedback, output feedback, counter mode, which is used in IPsec. Next is 3DES, which has a 112-bit effective key length and uses either 2 or 3 different smaller keys in one of several modes. The modes are EEE2 or 3, EDE2 or 3. AES is one of the most popular algorithms used in crypto systems nowadays. It was brought as a replacement for DES in 1997. It uses the Rijndael algorithm, supports key or block sizes of 128, 192 and 256 bits, uses 10 or 12 or 14 rounds as block size increases. Next is IDEA, which stands for International Data Encryption Algorithm. It operates on 64-bit blocks in 8 rounds with 128-bit key. It is considered to be stronger than DES and is used in PGP. Blowfish is a 64-bit block cipher with up to 448-bit key and 16 rounds, which was developed by Bruce Skinner. Now some common asymmetric algorithms are Diffie-Hellman. It was first widely known public key cryptography algorithm. It computes discrete algorithms over a finite field, provides means for secure key exchange over insecure channel. The second is RSA. It stands for inventors' name Rivest, Shamir and Adelman. It relies on difficulty of finding prime factorization of large numbers. The third is El-Gamal. El-Gamal is based on Diffie-Hellman method of computing discrete logarithms. It can also be used for message confidentiality and digital signature services. The fourth is elliptic curve cryptography, in short ECC. ECC relies on computing discrete algorithms over elliptic curve group. Due to difficulty of problem, key sizes can be much smaller than RSA and still retain the same strength. Along with the aforementioned algorithms, certain hashing algorithms are also commonly used nowadays. Some of them are MD5, SHA1, HAVAL, and RIPE MD160. MD5 is based on MD4 and was created to address vulnerabilities found in MD4. MD5 generates 128-bit hash values over 512-bit blocks in 4 rounds of 16 steps each. SHA1 also operates on 512-bit blocks but produces a 160-bit hash value in 4 rounds of 20 steps each. MD5 is widely used for file integrity checking, while SHA has its uses in digital signatures. Public key infrastructure deals with various aspects that an IT professional has to take into account while implementing a public key-based cryptographic system. All the components needed to enable secure communication here are policies and procedures, keys and algorithms, software and data formats. One of the major functions that a PKI is supposed to achieve is the assurance of identity to users. In addition, it provides key management features which include issuance, revocation, recovery, distribution, and history. Some of the essential PKI components include digital certificates, certificate authorities, registration authorities, and certification revocation list or CRL digital certificates adhere to the X509 certificate standard format. CRLs are maintained by the CA and list all certificates that have been revoked. Clients are supposed to check if a certificate has been revoked before using it, but this is not always the case in practice. To issue proper chain of trust, the verification of root CAs is done through cross certificates. As is obvious from the figure, the root CA of a forest is verified and validated by an adjacent root CA, thus promoting trust among adjacent domains in the organization. With several other facets, cross certification offers to stamp the domain controllers according to trust models issued for the particular environment. Thank you for exerting such perseverance. We shall now move forward with the demonstration of the concept of cryptography.
Let's start with the demonstration of cryptography. I am using the website online application and cipher it. So just look there. I'm using and cipher it. Just in the sample text, we have to put our message which we want to encode and send it through the mail. I'm typing welcome to Innovus. Okay, and I want to encrypt this, so I can select this and separate. Now I have to put the encryption key. I am taking one encryption key and encrypt it. So this is the encrypted mail. So I have to send it. Now click here on Gmail. Just give the recipient address. So this is the recipient address. I'm giving the example is give the subject cryptography example. Okay, and send it. So my message is sent. Now at the receiver end, what will happen? Let's see. Now wait for the message to receive. Now we'll got the message. Let's check. See, this is the message we received, sent by the sender. Now select this message and click here. Now I have to put the encryption key, which I have already submitted there. See, we'll got the message. Welcome to Innovus. It means that whatever the thing we have transferred from our source to destination, by using the email, we encrypt it. We convert the plain text into ciphertext by using the online service of Encipher it. It will encrypt our information by using their encryption algorithm and send it through the mail. So it will be most convenient way to send our information. Suppose suppose someone compromise our email, still we have one encryption, so that we can save our encryption, our methods, or we can save our data from being sniffed. So this is the example of cryptography.
Aside from cryptography, steganography is a common concept which is used to provide data security. It focuses on the term security by obscurity, which means that the existence of data is hidden in order to protect it. Steganography originated from the Greek word steganos, meaning covered, and the Greek word graphy, meaning writing. Steganography is the process of storing a secret message with ordinary content, generally images, and then extracting the message when it reaches its destination. Anyone else who views this message is not able to see the hidden data. Steganography has a wide variety of users, ranging from security professionals to terrorist groups, with each focusing on achieving their own ends. Steganography is used in the corporate world to face corporate intelligence attempts. It is also assumed that terrorist groups make use of steganography to seriously communicate internally. The rumor is that some terrorist organizations use steganography by posting some images on random websites and secretly share the information online. In this way, their messages are transferred without any interception from law enforcement agencies. Even if the transmission is intercepted, it becomes increasingly difficult to extract the hidden message. The function of steganography is fairly simple. Here we have a message file which contains the message which is to be hidden. and a cover file behind which the message is meant to be hidden. When combined, it creates an output file which looks exactly similar to the cover file, thereby eliminating suspicion of any hidden items. It is important to select a suitable cover file in order to minimize the degree of suspicion. For that, a list of compatible file extensions are showed here, which are effective in hiding the data from plain sight. Some of the file extensions are BMP, JPEG, GIF, WAV, and MP3. Some of the tools which are commonly used for steganography are Steganos, S-tools for hiding data behind GIF and JPEG, StegHide, which is used to hide data behind WAV and BMP files, Invisible Secrets for hiding data behind JPEG images, JPHide, and Hiderman. Focusing on the security aspect of such techniques, we shall now look into the concept of steg analysis. Steg analysis is an art and science of detecting message hidden by steganography. Steg analysis can thus be considered as a pattern recognition process to decide which class a test image belongs to. The key issue for steg analysis is just like the pattern for recognition and feature extraction. The feature should be different for the image without hidden message and for stego image. Now, steg analysis can be tedious and difficult task as the steganography methods have become sophisticated in current times. Some of the tools which might help in detecting the use of such methods are EnCase by Guidance Software Incorporation, iLook Investigator by Electronic Crimes Program, Washington DC, and various MD5 hashing utilities which checks for file integrity by comparing MD5 hashes. Steg analysis and cryptanalysis are important tools in solving digital crime cases. Understanding the how and what of the files and methods used goes a long way to provide an insight into such operations. As we have seen right now, the encrypted message is present in the source file, for example image. To get the message, we have to do cryptanalysis. Cryptographic algorithms are used for hiding data. Hence, cryptanalysis is required to recover the message. Another way of recovering data is by employing password cracking method. Try to guess the password using social engineering technique and brute force attack to extract the original message. Steganography can be used as a weapon if the individual using it has negative intentions. Research and analysis is the only way to detect the steganographed image. Nowadays, various free tools are available online for steganography. In comparison, the number of tools for steg analysis is less and poorly developed. These cases fall under the domain of computer forensics.
Let's start with a demonstration of steganography. I'm using the tool Invisible Secret. Now I want to hide my information which is contained in the text file behind the image. So I'm making a text file. Now I have to put some information in that text file. So I write this file contain important data. Now and save it. Now this is the carrier file and this is the source file. By using this tool Invisible Secret, I'm hiding this information contained in text file behind that image. I click on hide file. See, select the file you want to hide in the carrier. Click on add. Search for this file. This is the file. Okay, put next. This is the file name behind that I want to add my data or hide my data. So this is the carrier file. I have to select the koala, the image. Okay, now put next. I have to put the password. I put the password. I have to select the encryption algorithm. By using this algorithm, I have to encrypt the data also. I can use any of the algorithm, RC4, Ghost, you can select the algorithm. And thing to be remembered that the recipient should have the same tool and you have to share your password and the encryption algorithm After that, he can able to see your information. Otherwise, nobody will can see the information which you have encrypted behind that image. So I put next. The target file means the output of the file. I put final and then height. Start encrypting it. Next, I can explore the output from here. So this is my final output image which contain the information, and finish. So this file contain the information. Let's check. I'm going to delete this images. It means I only have this final image. So I want to see what kind of information this image contain. Let's check. I'm using the same tool. Think that I'm a receiver. I receive this file. I want to see what kind of information attached behind this image. So I click on unhide. I have to select the source file. Right now it's final. Now put next. I have to use the password because it's mandatory that the receiver should have the password. And then I have to select the information. If I select some other information, other encryption algorithm, then it will not give you the result. If you want to check it, you can check it. See, it will say invalid, access denied, invalid carrier file, password or algorithm. It is not specified that which information is wrong, whether you are giving the incorrect file or you are put the incorrect password or algorithm. So we have to select the correct encryption algorithm. After that, I have to put next. Let's see, I have a file. I unhide it and keep the original path. Unhide it, and now I have to put explore. If you explore it, see there is a file. Okay, this file contain important the same file which I have deleted first. So this image, the final image contain the information and we can retrieve it. So this is the example or the demonstration of steganography. We can also use encryption and decryption of this tool. Let's see how. Again, I make one text file. I put some information in this file. This file contains important information, and I save it. Now I have to encrypt this file. Click here. Add the file which you want to encrypt it. I put the name. This is the file. Next, I have to put the password. Now at that time I will change the encryption. I used ghost and encrypt it. Finish. Let's see. I have got the encryption file. I will delete this file. Now see, I have only the encrypted file. Suppose this is the receiver file. You send it by mail or by using pen drive, and the receiver want to see what kind of information the file contains. So he has to use the same invisible secret. Let's see. You have to decrypt it. Add the file. You have to put the enormous. This is the encrypted file. Open, and then next you have to put the password and the algorithm. I have select the ghost and decrypt it and finish. Let's see, we got the file. So this is the demonstration of the encryption, also encryption part of invisible secret. This file contains important information, means it is the same original file which we have created right now. So this is the demonstration of invisible secret.